Python programming language on your computer, basically, so that your computer knows how to run Python. And you will find different installation packages here depending on your operating system. Next, once you've done so, you can go to the second link, which will bring you to PyCharm website, which is an IDE, basically a program that we use in order to develop Python applications in. And you can download a PyCharm here, and either you choose macOS or Windows or whatever you have, and you choose the community version. And so once you've done so, for all of you watching live, you can do that after the stream or just during the stream. Once you've done so, you will have PyCharm on your computer. That's what happens when you have live television. Anyway, guys, what you need to do is, once again, we can take it once again. You go here, you go to New Project, you select your project wherever you want to put it, and then what you need to what you need to do is that you go to here, to File, and you click on Settings, and and here you see this list of the different packages you have installed, and you can click here on the green cross, on the green plus sign, and here you need to search for Bitcoin, and then you can install the Bitcoin package, right? So, and once again, it is created by Vitalik. And once you've done so, we can actually start working. So what you do, first of all, let me just delete this. Where do you have delete here? So first of all, you right click on your project that you should have created, and then you go here to New, and you create Python file and call this main. So we'll have main. And so first of all, when we start coding this, we need to import the library we just downloaded for our project here in settings. So what we do is that we write from Bitcoin import star. So when we do like this, we basically say to our computer, we basically say to Python, just import everything you have, from this Bitcoin library that we just downloaded together. And then we can start playing around. So there are a couple of things I wanted to show you. First of all, we will generate some addresses. So your wallet, it needs to generate your addresses. It needs to do it locally on, for example, if you have your hardware wallet, well, your hardware wallet needs to know how to generate new addresses. And something that you can do is, for example, create a variable in Python like this. Let's call our variable private key. So we're actually creating a variable. And to create a private key, there is a function in this Bitcoin library called random key. So if we just want a random private key, we can write random key and then two brackets. And now we can also use the print function in Python to print the private key like this. So to have this running, you can go to run and then click on run here. And then you see the output here. And if you want to run it, you can also click here on this green arrow right here. And now you see that we have created a private key here like this. And so this is how you can create a private key in code, and this is how your wallet would create a private key by, for example, running this function private key. And next, what you can do is that you can actually generate a public key from this private key. So you know that you have your private key, and it is then used in order to generate your public key. And so to do that, we can create a new variable called public key, and it is equal to priv to pub. So we can use this function called priv to pub to convert our private key to a public key. And so we just enter it in the brackets like this. And then if you click on the green arrow here in the corner, here in the lower section, and click on this, you will see it running, and now we have our public key, private key here. And so we actually need to print this, and if we print our public key like this and click on the green arrow again, now you actually have your private key here and your public key. And so the public key is generated from the private key. And each time you run this code, each time you run it, you see that the private key and the public key are different, because each time you run the code, we're actually generating new private keys, and then of course the public key is different. And next, what we can do is that we can also generate an address from this. And what you can do is that you can write address, basically a Bitcoin public address that you would give your friends if you want to receive Bitcoin from them. Then you can use private key priv to address like this. Or actually, let's do public pub to address. So you can actually use your public key and convert it to a Bitcoin address like this, and then you can print it out. So if we now click on the green arrow here, you see that here's our private key, here's our public key, and here is our Bitcoin address. And so, as you can see, having the private key, the computer can generate the public key and the address. And therefore, what you really need to keep track of is your private key. And your public key and the address can be generated from the private key. And sometimes people confuse this notion of a public key and an address, because those are two different things. A public key is this long thing we have here under the private key. Let me see where my mouse is. This is the public key. And of course, sharing this long thing is not practical, and therefore we can convert the public key to an address like this. So this is how your wallet would generate new addresses. And when we're generating new addresses and new accounts, the thing is, we don't need to check with the Bitcoin network whether those accounts are already created or whether those accounts are already taken. And you can watch in the description and see a video I did a few months ago. Basically, it is called "Is Bitcoin Running Out of Addresses?" And there you can really see that the number of addresses is just so mind-blowing. It is just so gigantic, so we can just generate new private keys, just randomly generate new private keys, and chances that we generate a private key that is already used are basically zero. They are so small, they are negligible. And so we just generate a random number, which is our private key, and then a public key. But the problem currently is that each time you run the program, you get new private keys, new public keys, new addresses. And this is because we have random here. What we can do now, which is quite interesting, is that we can create a brain wallet. So basically, we can create a brain wallet so that we only need a password in order to access our account. So for example, this is how you would do it. You would write SHA-256, and then you need to enter your password, your brain wallet password. So, for example, let's have what is going on. as our password. And now when I run the program by pressing the green arrow here, you see that this is our private key, this is the public key, this is the address, and if I run it again, it is the same. And so, in that sense, you have your brain wallet. And now I can basically throw away this program, I can throw away this computer, the hard drive, just leave everything, and as long as I have this password, I will be able to recreate my account on another machine. Because I just need to run this code on some other machine and I will get exactly the same private key, public key, and the address. So this is how that works. And of course, if we change this slightly, for example, if we change a letter and run, well, suddenly everything is different. And it's not even close. The things are completely different. Alright. So this is how you do addresses. And next thing I want to show you is how you can do multisig. So, multisig is this feature in Bitcoin that in order to send a transaction, you actually need several signatures with several different private keys in order to use accounts in locked up in an account, in an address. And so, to do that, what we can do is that we can just create 3 different private keys and public key pairs. So, for example, here I have private key 1, public key 1, address 1, public key 2, private key 2, address 2, and then 3, 3, like this. So now I have 3 different pairs. And also let's just create this random key. And we will just use random key to generate everything. Of course, now I need to update this, and this, and this. And so what I can do now is to write the following. Now I can create this script, which is the multisig script. So I can write multisig script equals make multisig script, mk multisig script. And now I can specify that I want to use this public key, I want to use this public key, and I want to use this public key in order to access this particular script. Alright? And then I also need to specify how many of these keys should be used. So, for example, in Bitcoin, you can have this feature that instead of having all private keys to a multisig wallet, you only require 2 of 3 public keys, or 1 of 3 public keys, or 4 or 5 private keys in order to sign the transaction. So, in this instance, let's say that in order to use the funds locked up in this multisig address, we need 2 out of 3 private keys. So, we use the public keys to create the multisig script, and then we will have to use the private keys in order to access it. And so when we do like this, we can now print out this multisig script and run the program, and now we see that this is our script that we have generated. But as you can see, it doesn't look like a script address. So instead there is this function called script to address, and we can call the variable multisig script address, and then convert script to address and give multisig script as a parameter, like this. And now when I print the address and run the program once again, well, you see that this is or actually this should be script adder, like this. And when we run the program, you see that here is our multisig script, and here is our multisig address. And you see that the address starts with a 3. And this is how we know that it is a multisig script address. What else? Well, if we print, just to show you that you can actually see that some addresses are multi-sig. So for example, if I print address 3, which is just a normal Bitcoin address, you see that this one is starting with a 3 because it is a multi-sig script address, and this one is starting with, it doesn't start with a 3. And so this is how we can actually see the differences. So guys, we have 400 people watching, almost 450 people watching this stream. Amazing to see all of you. Make sure to smash the likes and the bell button, guys. I would really appreciate that. And I see in the chat, James Rogers, completely right. We need to smash the likes. So this was the first part, that we have created some private keys, we have created some public keys, and now I want to show you how to see history. So first of all, let's go back to Safari, the browser, and let's go to blockchain.info. And here we can just enter a block, and let's find some address. For example, let's take this address. So I'm just taking a random address I see in the on the website. And now if we go back to, let's see, now if we go back to PyCharm, we can actually start messing around with history and retrieving history for an address. So let's write address history. We are creating this variable, and we can actually just use the history function like this, and then insert an address like this. And now if we print this address history, we should get the history of everything that happened to that address. And so when I run this by clicking on the green button here, we see basically all the history. That we have an output here, and this happened in this block, and if we scroll, we see the rest. So this is actually how we can build applications using the Bitcoin blockchain, by, for example, querying history, or what we can do is we can also query unspent transaction outputs by writing unspent like this. And if we run this, well, we will get all the outputs that are unspent. So here you have an output, and here you also have the value for that output. And you can see all of the different outputs that this address has. So guys, that's really it. I don't want to make it too long, but I hope you learned. And sorry for the issues in the beginning. And you know, actually, I think the pop-ups weren't showing in the beginning. And so let me just show you once again. Basically, what I want to do is that I want to, let's see, because there is an issue here with the, let's see, okay, if I do like this, you should see the entire screen now, and not only a window. And what we need to do is that we need to